Okay, now we're dealing with mixed stoichiometry problems. So now we have the full combination of the mole concept along with stoichiometry. So now we could be dealing with units of mass, so grams, units of volume, liters, milliliters, centimeters cubed, and particles, so atoms, molecules, or formula units. So we have the full integration of everything that we learned with the mole concept in stoichiometry. And just like our other stoichiometry problems, we're going to begin number 6 here with our dimensional analysis setup. That's my first step. My second step, what is this question asking me for? And it says right here, how many liters of H2? So that's what I'm working towards. I'm trying to get to liters of H2. That's what I am trying to end up in. That's my ending unit. That's my second step. My third step is to identify my given. So here is my given, 803 grams of magnesium. So that's going to go right over here, 803 grams of magnesium. All right, so now I'm going to start looking for those keywords. And this was our same approach when we were dealing with the mole concept. Keywords, essentially the units, are going to identify what conversion factors I need. So if I look right here, grams tells me that I need a molar mass conversion factor for magnesium. And then I've got liters over here that tells me I'm going to need a volume conversion factor. But before I get to any of those, I kind of got a little ahead of myself. I want to make my mole ratio. So that's the first conversion factor I should make, is my mole ratio between this substance and this substance. So I'm going to get that from my balanced chemical equation. That's already been provided for me. So I have my balanced chemical equation here. I see I have 1 mole of hydrogen and 1 mole of magnesium. So I'm going to write that off to the side here. 1 mole of magnesium to 1 mole of hydrogen. All right, now I can start looking for those keywords. So I need a molar mass conversion factor, as I said, for magnesium. So 1 mole of magnesium has a mass of 24 grams of magnesium. And then I see liters here. Now, this problem doesn't say it, but we're just going to go ahead and assume that this is at standard temperature and pressure. So we'll say that liters tells us that I need my third conversion factor, which is moles to volume, 1 mole of any gas at standard temperature and pressure. So in this case, hydrogen has a volume of 22.4 liters. And those are all of my conversion factors, and I can go ahead and start plugging them in. So I've got grams of magnesium here, so I want grams of magnesium here. So I'm going to go ahead and use this conversion factor. And I don't need to flip it over. I'm going to plug it in just the way that it is. So 24 grams of magnesium to 1 mole of magnesium. Not to where I want to be yet. I want to get to liters of hydrogen. I'm in moles of magnesium, but I'm not going to use that anymore, so I'm just going to cross it out. So next, I'm going to use my mole ratio, because that has moles of magnesium in it, and that's what I'm in now. In this case, I'm going to have to flip this over. So 1 mole of magnesium goes down here, and 1 mole of hydrogen will go up here. Cross that out. Now I have 1 more conversion factor left. 1 mole of hydrogen. Again, I'm flipping this one over, so I get moles of hydrogen on the bottom is equal to 22.4 liters, and that is hydrogen. I should have put that right there. All right, so now all I have to do is my math and multiply 803 times 1 times 1 times 22.4, and then divide that by 24 grams. And that gives me 749.47 liters of hydrogen gas.